Okay, so sections 7.3 and 7.4, in my opinion, go together very nicely. In fact, I'm not sure why they're separate, so I'm covering them together as one section, and I'm doing so before section 7.2. Again, just kind of more of trying to follow more of a natural flow of how things happen rather than just following the book's order. So, okay, we're going to start by defining the 6 trig functions. Okay, we're going to start by using what we call the unit circle. The unit circle is the equation x squared plus y squared equals 1. It has a center at 0, 0 and a radius of 1. So circle, it hits 1, 1, negative 1, negative 1 because its radius is 1. Okay, and it centers right there at the origin. So if you look at any angle in standard form, that means its vertex is at right here at 0, 0. There's its initial side, terminal side, just somewhere. I just put it right here. Where it touches that circle, where that terminal side of that ray intersects the circle, is a point, x comma y. All right, and then this circle, this angle right here that's made inside that circle, I'm calling it the Greek letter theta. Okay. We typically use Greek letters, remember, to represent angles. So, because the radius is 1, the arc length formula, from the last section, is S is equal to r theta. If r is 1, that just means that S is equal to theta. That means that whatever angle this is in radians is the same as this arc length. Okay, so we get the definitions of the 6 trig functions. So the 6 trig functions are sine, cosine, tangent, cosecant, secant, cotangent. These are functions that show up enough that we've just given them names. Okay, so the sine is abbreviated sin. So we say this is the sine of theta. Just like in function notation, if we talk about f of x, this is the sine of theta, or it's just sine theta. The sine is defined as being the y value of this point. The cosine of the angle is defined as being the x value. The tangent is defined as being the ratio of y over x. Again, y, x. The cosecant is abbreviated CSC, and its definition is 1 over y. Now that's, of course, provided that y is not 0. The secant is defined as 1 over x, provided that x isn't 0. And the cotangent is x over y, provided y isn't 0. These three down here, the cosecant, secant, and cotangent, are what's called the reciprocal functions, because you might notice that they are the reciprocals of these three. So look, if you take the reciprocal of sine, the reciprocal of y, because you can think of it as y over 1, is 1 over y. The reciprocal of x over 1 is 1 over x. The reciprocal of y over x is x over y. So for that reason, those are called the reciprocal functions. All right, so let's use the unit circle to find the values of the following. Now, if you've had a trig class before, you might already know this stuff, in which case that's awesome. Okay, but if you don't, I'm here for you. The sine of 60 degrees. Now, remember, from the definition of the circular functions, the sine is the y value. So we need the y value of the point associated with 60 degrees. So we break out our unit circle, and this formula sheet is located in D2L for you, so you can print it out. So if we look at 60 degrees here, you'll see, oh, it's so little, is right here. That's the point 1/2 comma root 3 over 2. So the angle at 60 degrees, that terminal side passes through the circle at 1/2 comma root 3 over 2. This is the x value, that's the y value. Since the sine is defined as being the y value, then we say the sine of 60 degrees is root 3 over 2. Now, if you were to use the calculator, so if we go to mode and go to degree mode, So you can see I just changed it to degree. And then the sine of 60 degrees is about 0.866. If you do the square root of 3 divided by 2, you'll see that's the exact same decimal. Some of these show up so often that, you know, I just kind of recognize that 0.866 as being root 3 over 2. So don't be surprised if you start recognizing those decimals and, you know, just know what those are. All right, cosine 60 degrees. Well, the definition of the cosine is that it's the x value of that point that terminal side goes through. Well, we still have, you know, there's the terminal side. The point was 1/2 comma root 3 over 2. So the cosine is the x value. So if we look at the x value, we get the cosine of 60 degrees is 1/2. That's an easy one to check on the calculator. So we just go cosine 60 and we get 0.5. The tangent of 0. All right, so 0 degrees is right here where my initial and my terminal sides overlap. The point on the circle is 1, 0. X is 1, y is 0. And the tangent's defined as being y over x. So that's going to be 0 over 1, which is just 0. You can check that one on your calculator as well if you wanted to. How about tangent pi over 2? Well, again, the definition is y over x. Pi over 2, you'll recall, is 90 degrees. Now, where am I getting these points from? I'm getting them all from this unit circle. Okay? You can use the unit circle that's in the book. You can, if you have a different formula sheet from somewhere else, you can use it. You can use my formula sheet. All the unit circles are going to be the same. So this point up here, this is 90 degrees. So that point on the circle is 0, 1. The tangent's defined as y over x. So y is 1, x is 0. 1 over 0 is undefined. It's not 0. All right? Look, if you don't believe me, 1 divided by 0, it's giving me a divide by 0 error. If you wanted to do tangent of pi over 2, well, pi over 2 is 90 degrees, just because I've already got my calculator in degree mode. You get a domain error. That's because that particular value is not in the domain of the tangent function. We'll see why later on when we graph them. All right, how about the secant of 5 pi over 3? So we look up the definition of the secant function, and that's 1 over x. Now, for now, you might notice on this formula sheet that the circular function definitions I gave you don't look like the ones I just did. That's because those are very short-lived. We will eventually bring in a radius other than 1 and just say, hey, if r is 1, then you'll just get y. No. So you can still use these definitions. You know, sine, we said it was just y. Well, yeah, because the unit circle r is 1, so it's y over 1. So you can still use these definitions. Okay, so definition of secant's 1 over x. So we need the 5 pi over 3 point. So where's 5 pi over 3? Well, in my unit circle, if you look, it's really, really small, but it's right here is 5 pi over 3. See? And it also says right there 300 degrees. And you can see that point associated with it is 1/2 comma negative root 3 over 2. So there's the point associated with 5 pi over 3. It's 1 over x, so we get 1 over the x value of 1/2. Now it's interesting to note that 1 over something is the same as the reciprocal. So 1 over some stuff is the reciprocal of that stuff. So what's the reciprocal of 1/2? Which is 2. If you don't know that, or if you don't, trust yourself or something, you can do 1 divided by 1/2. So if you wanted to do it that way, you certainly could. All right, so now let's do one where we're going to find the value of all 6 trig functions at one particular angle, pi over 4. So pi over 4 is halfway into quadrant 1. So if you look at the unit circle, it's right there, 45 degrees, pi over 4. And this little teeny tiny point right there is root 2 over 2, comma, root 2 over 2. So enlarged right here for your viewing pleasure. All right, so let's look at the definitions. So we have the definition of the sine, the cosine, and the tangent. So the sine is defined as y, cosine is defined as x, tangent is defined as y over x. All right, so the y, well, this one's a little bit easier, right? Because x and y are the same. So if you get them backwards, it's okay. So there's the y, there's the x. Y over x, well, look, that's just going to be 1 because it's something over itself. That's the same thing on the top and the bottom. Okay? These reciprocal functions, they're a little trickier. The cosecant of pi over 4 is 1 over y. So we do this 1 over root 2 over 2. Remember, 1 over something is its reciprocal. So I did 2 over root 2. So I just took the reciprocal of that stuff. Rationalized it by multiplying by root 2 over root 2. That's just 1. And I get 2 root 2 over root 4, or just 2. Those 2's cancel, and I get square root of 2. For secant pi over 4, it's defined as being 1 over x. Right? So it's just 1 over x, which is the exact same thing. Look, 1 over root 2 over 2. So what I did was I didn't go through all this again. I just kind of was like, hey, I've already done this like 4 seconds ago. So it's going to be simplified to be the same thing, that root 2. Cotangent is x over y. And just like last time up here with the tangent, I get the same thing on the top and the bottom. So I get 1. Okay, so let's talk about some identities here. And these are on your formula sheet. So we've got our reciprocal and our quotient identities. So those are all down here. Okay, so you'll see we got the unit circle up there. We've got our velocity and our arc length formulas. Remember all those? We've got the circular definitions. We're going to do the right triangle definitions in the next section. And then we got our reciprocal and our quotient identities. On the other page, so normally I would print this front and back and laminate it for you in class. So if I ever get to see you guys, I will, I'll do that. I can give you one of those. So the even odd properties here, Pythagorean identities, graphs, asymptotes. So if some of this looks like, hey, I don't know what that is, it's because we just haven't got there yet. That's all. All right, so let's talk about the reciprocal identities. So as I pointed out earlier, the sine and the cosecant are reciprocals of each other. Okay? So we can say that the sine is 1 over the cosecant. Because remember, reciprocal is 1 over something. You could also say cosecant is 1 over sine. Same thing. You know, so those mean the same thing. The cosine is 1 over the secant, or you can say it as the secant is 1 over the cosine. The tangent's 1 over cotangent, which means the cotangent's 1 over tangent. Okay? So in general, we say sine and cosecant are reciprocals, cosine secant are reciprocals, tangent cotangent are reciprocals. Then we have the quotient identities. Right? So we have that the tangent is sine over cosine. Well, yeah. Remember, tangent was defined as y over x, sine was defined as y, cosine is x, so okay. And the cotangent is just the reciprocal of the tangent. So it's just the reciprocal of this. Cool? You could use these now instead of having to go back and use the definitions for all 6 trig functions. So what I usually do is I just memorize these 3 definitions and then use reciprocals and quotients for the rest. All right, so last example for this part. Given that sine is 2/3 and cosine is root 5 over 3, find and simplify the remaining 4 trig functions. So here's the 6 trig functions. We've got sine, we got cosine. So here's the 4 that we need to find. We can find these in any order, right? It does not matter what order you go in. I just chose the cosecant to start with because it's 1 over sine, and I've got the sine right there. So it's 1 over 2/3, the reciprocal of which is 3/2. Okay. So I just went ahead and wrote this out in case you wanted to see that reciprocal business. It is just 1 divided by 2/3, or 1 times the reciprocal there. Or you could use a calculator, either one. All right, how about the secant next, since it's just the reciprocal of the cosine, and we have the cosine. So the reciprocal of root 5 over 3 is 3 over root 5. This one's a little trickier because I have to rationalize it. I got to get rid of that radical down here by multiplying by that over itself. I get 3 root 5 over root 25. Root 25 simplifies to just be 5. Don't cancel those 5s. That one's under a radical and that one's not. So I get 3 root 5 over 5. All right, 2 down, 2 to go. All right, so I've got cosecant and secant. Those are just the starting points I chose. You certainly could have chosen to start with like the tangent if you wanted to. The tangent is sine over cosine. So we were given that sine is 2/3, cosine's root 5 over 3. So what this means is we're going to take 2/3 divided by root 5 over 3. So all I did was write this fraction bar as a division symbol because it means the same thing. Because you know how to divide fractions. It's multiplying by that reciprocal. So if I multiply by that reciprocal, those 3's cancel. I get 2 over root 5. And once again, here we go again with that rationalizing. I get root 5 over root 5, so 2 root 5 over root 25. So the tangent is 2 root 5 over 5. The cotangent, the last one, it's the reciprocal of the tangent. But I didn't use the reciprocal of this answer. I used the reciprocal of this because this is the same as this before it was simplified, before it was rationalized. So I took this because I knew that when I flipped it, I'd get root 5 on top, 2 on the bottom. If I had chosen to flip this one, do you know what would happen? I'd get a root 5 in the denominator, and then I'd have to rationalize it by multiplying by root 5 over root 5, and then I'd have to reduce, and guess what I would get? Root 5 over 2. So, yeah, so you could use any of these along the way to help you. All right, so that concludes the first part of sections 7.3 and 7.4.